All right, let's try to figure this one out. Let's continue on with some exploration here. Tangent of x minus the sine of minus x all over 1 plus cosine of x. Does that equal tangent of x? So let's try to verify this identity. And I think this is going to, again, have a couple of steps involved. So, finish the popcorn you had in the last section. First thing I kind of notice I have over here, I have the sine of minus x. First time we've seen that, so maybe this is an opportunity for us to remember some of our even odd functions. So let's go ahead and work with that. And the tangent of x, I want to change those to my sines and cosines as well. So let's rewrite both this expression and this expression. Well, now let's just do one at a time first. So tangent of x minus the sine of negative x is an odd function. So that can also be written as the minus of sine of x all over 1 plus cosine of x. Minus a negative makes that a positive. So let's hold off on that for a second. I'm going to take tangent of x and write that as my tangent of x is sine x over cosine of x. So sine of x over cosine of x, that's tangent. Subtract a minus becomes a plus, sine of x all over 1 plus cosine of x. Again, I don't think that's something that's unusual. If you're following along, try and do that your first time. You probably won't have success, but your second, third, or fourth time, you may have success doing that. All right, let's figure out what we're going to do next. Let's look at the numerator and let's add those together by getting a common denominator. So sine of x over cosine of x plus sine of x. Let's multiply that by a cosine of x all over cosine of x. That's a clever version of 1. Multiplying those out, I now have sine of x plus sine of x times cosine of x all over, let's add those together, let's just put those all over cosine of x. So that's in the numerator. I still have my denominator, which is 1 plus cosine of x. So let's rewrite that up here a little bit so we can kind of see better where we're at. Sine of x plus sine of x, cosine of x, all over cosine of x, all over 1 plus cosine of x. So looks like I now have a complex fraction I can deal with. So let's deal with, well, I can deal with the top as well. So there's a couple things I can do. Let's do the numerator first. Let me factor out a sine of x. And I'm left with 1 plus cosine squared, or not cosine squared, but cosine of x, all over cosine of x, all over 1 plus cosine of x. Now let's go ahead and deal with my complex fraction. So this becomes sine of x, 1 plus cosine of x, over cosine of x, multiplied by 1 over 1 plus cosine of x. Since these two terms are being multiplied, that means that I can look for clever versions of 1. And the clever version of 1 I have right here is 1 plus cosine of x and 1 plus cosine of x. I can clever version of 1 those out or cancel them. So I'm left with on the numerator sine of x. In the denominator, I have cosine of x. And the sine of x and the cosine of x is an identity, which is the tangent of x. So I was able to verify that identity to indeed be true.